So when you want to do shadows in computer graphics in 3D, there are three main approaches. The first one is called ray tracing. You may have heard of it. It's been in the news a lot in the last 4 years or so. This really should go without saying, but I am not going to be writing a ray tracer today because 1, I am not insane, and 2, I am not this guy. So that leaves us with two other main options, light mapping and shadow mapping. Light mapping and shadow mapping are not, as the name implies, a feud between two opposing factions in some weird nerd version of D&D Pathfinder. However, I assure you that they are both quite cool. Today we're going to be talking about shadow mapping. I'm sure I'll get to light mapping at a later date. So as you can see here, I have a 3D scene, and this is fairly similar to the 3D scenes that I had in previous videos. We have the pirate ship, some balls, we have some trees that have been randomly placed throughout the map here. There's also a directional light shining on everything. That's fine. I added the trees just so that when we start casting shadows, we have more than just a small number of objects to 1, cast shadows onto, and 2, cast shadows with, just to make the scene a little bit more busy. I'll also specify that today I'm only going to be dealing with shadows with directional lights. You can do shadows with point and spotlights, but I'm not going to be worrying about that right now. So as with pretty much all of the 3D and GameMaker videos that I've been making lately, and pretty much all of the 3D and GameMaker videos that I'm going to make from here until the end of time, there are a number of prerequisites. Before you try to do this, you are going to want to understand a few things. Those things are, in particular, everything, but more specifically, orthographic cameras. I made a video on this a few weeks ago. And also rendering depth to a surface, which is also a subject that I made a video on a few weeks ago. Things like how a 3D scene is put together and what the camera does and how 3D lighting works and shader math in general are all things that you'll also want to know, but again, at this point I feel like that should go without saying. Please do not try to follow this video if this is your first time delving into the world of 3D. So first, let's talk a little bit on how a shadow actually works, and I'll make this brief, I promise. So you have a light source, let's call it the sun, let's just say it's this ball hovering above my head. It's a very ad hoc sun, but it'll get the job done. This thing is emitting light, and we have a point, let's say, over here, and if this point where we're standing is in direct sunlight, if there's nothing between us and the sun, then we will not be in shadow. If there is something between us and the sun, let's say maybe we're over here, right behind this tree, then we will be in shadow. And thinking about shadows in that way, more or less cuts our work out for us. We have to figure out, for every point in the scene, if there is something between us and the light source. How do we do that? So the first thing that we're going to do, and this might sound a little bit odd if you've never thought about it before, but the first thing that we're going to do is we are going to render the 3D scene from the point of view of the light. And that sounds especially weird when it comes to directional lights, bear with me. Generally, directional lights in games are used to represent sources of light that are, for all intents and purposes, infinitely far away, such as the sun. The light rays coming out of the sun are effectively all coming down on the world in parallel, because it's so big and so far away. We don't really think of them as originating from any individual point. A directional light is, after all, only defined by a direction, but nevertheless, we need to render the scene from the point of view of the light. And I'm going to pick as good a point as any and just make it wherever the sphere is hovering over the scene. So if you want the state of this project before I start messing with it, if you want to clone this project and follow along, look for the GitHub repository in the video description. I think I'm going to normally when I put my code on GitHub for these videos, the first commit is the state of the project before I start messing with it. But I think today I'm specifically going to make a new branch, and I'm going to call this from the beginning or something of that nature, so that it's easier for people to find. Anyway, so you can see how this is set up. This is fairly similar to the last handful of 3D videos that I've been making. Changes involve the number of trees that are randomly spawned around. Changes involve the sun XYZ and the sun DX DY DZ, which is the direction that the light is pointing in. In the draw all the stuff script, the sun is drawn at that XYZ position. The uniform dictating the direction of the light is set to the sun's direction variables. This is pretty straightforward. So to render the scene from the point of view of the sun, I am going to comment out this x from y from z from business because we will be coming back to that later. And instead I'll say var x from is going to equal sun x, var y from is sun y, z from is sun z. x2, y2, z2, this can just be the sun's position plus sun dx, sun dy, sun dz. This is the direction that the sun is looking. This really can be looked at as the to and from position of the sun itself. So var x2 is going to be sun x plus sun dx. Remember, sun dx itself isn't a position in space, but a vector. So if you want to get a position in space, that is the position that you're looking at, you need to take the sun's position plus the sun's looking direction. And var y2 equals sun y plus sun dy. Var z2 is going to equal sun z plus sun dz. I don't think I've explicitly talked about the difference between like a vector 3 that represents a position versus a vector 3 that just represents a vector, but is that a point of contention? Should I do that? Anyway, now if I were to run the game, we would see that the scene is rendered from the point of view of the sun. If I hit the arrow keys, move around, swing the mouse around, we cannot actually move because our camera is locked to the position of the sun. The data structure representing the player does exist in the game, but it's just not visible anywhere in the screen or anything like that. Okay, that is step one. Let me, I guess I said I would be committing changes as I go instead of just at the end, so let me render the scene from the point of view of the sun. The second thing that we want to do is we want to render the scene's depth to the surface that we're drawing on instead of the actual color of the scene, the actual color information of the scene. I believe when I made that depth rendering video not too long ago, I said something specifically about how this is going to come up when we do shadow mapping, and this is where it's going to come up. Let me create myself another shader. Apparently I already did, and I called it depth, and I'd like to get rid of that and build it from the ground up. Let me clone the basic 3D stuff shader. Let me call this shader depth. I am going to take this, I am going to set it when we draw all the stuff. Actually, you know what? I'm going to move the shader setting code outside of the draw all the stuff script. So we can like do that here. And then at the end we can shader reset. So what the depth shader is going to contain is it's going to be a little bit simpler than the actual 3D drawing. This is what the actual 3D drawing looks like. The whole n.l taking in the light's direction and the face normals into account. Instead, let's go to the vertex shader. We do not need the texture chord varying. We do not need the color varying. We do not need the world normal or world position varyings. I'm just going to give myself one single varying, and that is going to be varying float v underscore light depth. This is going to look an awful lot like the depth rendering shader that I wrote in that one video. Light depth is going to be defined as I had in that video, gl underscore position dot z divided by gl position dot w. I can carry this over to the fragment shader. I do not need the varyings. I do not need the light direction uniform. And you know what? I'm just going to verbatim copy and paste the 2 depth color code from the last time. So if I were to run the game now, this is going to look like, well, it's going to look like something all right. We are going to have something that is rather, I believe the word is psychedelic that people like to use to describe this sort of thing. Okay, we have a depth map, that's fine. It would be really, honestly helpful if GameMaker would let us access the depth buffer directly, but alas, it does not, so we've got to do it ourselves. This texture that we're seeing on the screen right now, this tells the game how far away each individual pixel is from the camera. We will soon be using this to figure out if any given fragment that you render in the actual 3D scene has a direct line of sight between it and the sun, and whether or not it should be in shadow. Okay. So the camera that we are rendering the world from the point of view of the sun is, this is a perspective projection. Since this is a directional light and we want all of the sun's rays to run parallel to each other and to not converge or diverge at a distance, we are going to want to instead use an orthographic camera for the sun. So let me close this and let me go back into the camera's draw event And instead of when we define the projection matrix like this, instead of defining the projection matrix using the field of view, and then let me just, you know what, let me maximize this code window so that I can just have more space. We are going to define the projection matrix using matrix build projection ortho. Where is ortho? There's ortho. Orthographic projections, as you are probably aware, take slightly different parameters than perspective cameras do. We are going to give this thing a width rather of, let's say 1600. Let's give it a height of 900. I believe that is the size of the application surface, right? Yeah, I'm pretty sure it's 1600 by 900. Z near, Z far, these can stay as whatever they are right now. That's fine. You may well find when you do your own shadow mapping that Z near and Z far don't necessarily have to be the same value that the regular game camera uses, but we'll just keep it that way for right now for simplicity. And now if I were to run the game, I'm gonna want, yeah, okay, let's make that negative 900 instead, because GameMaker. There we go. We now have the scene rendered from an orthographic point of view, from an orthographic camera from the light's point of view. The colors are a little bit different, that's fine. The distance of a fragment to the orthographic camera is not quite the same as the distance of a fragment to the perspective camera because of the way that lines converge. That's just because of the way the perspective works. I think I can close this window now. Let me make a new commit, and this can be render the... So we are not done yet. Instead of just rendering this information to the actual application surface that we're actually drawing onto, we would much rather render this information onto a separate surface that we can make use of at a later date. So I am going to go into the creative and I am going to create myself a surface. It may be tempting to make the dimensions of this surface, which I'm going to call shadow map surface equals surface create. It may be tempting to make the dimensions of the shadow map surface the same dimensions as the application surface. Let's call it 1600 by 900. If you really want, you can use like window get width or window get height or whatever. This is not recommended because we will be sampling from this texture later. Spoiler warning. And when you sample from textures, it really, really helps if that texture is of a size that is a power of 2. So instead, I'm going to make this 2048 by... And you can make this a square, you can make it not a square, you can make it 2048 by 2048, you can make it 2048 by 1024. Obviously, having a smaller shadow map surface will be more performant. If you want to have quality settings in your game, it might not be a bad idea to have a setting for the size of the shadow map surface, essentially the shadow quality. Myself, I think I'm going to go with 2048 by 2048 just because making it a square makes me happy. All that really matters is that this is of a size that's a power of 2. Pretty sure modern versions of graphics APIs don't enforce the power of 2 texture rule, but GameMaker is what it is, so we're gonna be running with that. So we're going to need to render the scene twice, one for real and one for the shadow map. Let me say shader set shader underscore depth. Let me actually do that before I set the camera matrices, because GameMaker has this fun thing of when you do shader set target, surface set target, like that, shadow map surface, and then at the end when you surface reset target, GameMaker has this fun thing where when you set the surface target, you have to apply the camera settings again, even if they already have been. I'm not sure why it doesn't do it automatically. Hey. Anyway, we have shader set, shader depth. We have set the target to the shadow map surface. We are going to set the camera matrices. We are going to draw all of the stuff over here, and then we're going to reset the target. I'm going to put this in a region. Actually, this should probably go in that region as well. And end region can go after you reset the target. Okay, that is the shadow map surface, and then there is the actual 3D scene. Like so. We can set the shader to the actual 3D stuff shader, so this is going to draw the actual world. set the lighting direction uniform. We do not need the lighting direction uniform in the actual, the light depth shader. I believe I said that. I'm pretty sure I said that, just in case I didn't. I'm saying it now. We can set the cameras matrices, the cameras to, from, and all that. We can do that now. We can go back to using this, the player position as our X from, Y from, Z from, and so on and so forth. Let me get rid of all that junk. We can go back to using our regular perspective field of view matrix for our projection matrix. We can camera apply, draw all the stuff, and then shader reset. If I were to run the game now, the game would just look normal. You would not be able to see the shadow map surface anywhere. This looks like what I had, 20 minutes ago? However, if I were to run the game in debug mode, and GameMaker is going to run the game in debug mode and allow us to pause the game while it's running and take a quick look at things such as textures and surfaces in the game, we do not have anything. Am I, what am I doing wrong? I have a feeling I am forgetting something, and that something is probably that I need to draw clear. Let's make the C black before I actually try to draw anything onto the shadow map surface. Alright, let's try that again.
Hey.
I feel like I started to do that a minute ago and then just got distracted by something else. Alright, let's pause the game, go back to graphics, and now, when we hover over surface 0, which is the shadow map texture, we can see that the scene is rendered from the point of view of the light onto the shadow map surface. Just so that in the future, if I want to see what the shadow map surface looks like, I do not have to run the game into debug mode and pause the game and go into the graphics tab. I am going to, in the camera's draw GUI event, where is it? That's down here. I'm going to draw surface. The surface is going to be a shadow map surface. Okay, so ID XY. It's not XY ID. The position can be 0, 0 on the screen. I'm going to draw this at like a very small size so that it doesn't take up the entire screen. Let's draw surface stretched. And the width can be, let's just draw this at like 400 pixels wide and 400 pixels tall. And now when I run the game in regular mode, we will be able to see the shadow map surface in the upper left corner of the screen. That's perfect. What else is there? So you may notice that this is looking a little bit stretched, and that is because in the camera draw event, when I'm setting the height and width of the ortho camera that's rendering the scene from the point of view of the light, the surface that we're rendering onto is of one size, is of 2024 by 2048, is by 2048 squared rather, but the height and width of our ortho camera is 1600 by 900, which was the aspect ratio of my actual game window. So I'm going to make the height and width of the ortho projection for the sun 2048 squared, negative 2048 on the vertical axis, and that is going to give us the same ratio, the correct as you will aspect ratio for the shadow map up here, so that it's not stretched weirdly. Again, if you want to introduce something resembling quality settings for your game, and you want to have like shadow quality or something, you may well want to have a variable called something like shadow map size. We can set this to 1024, and we can use this one individual variable in all the places where it's relevant. You can also do this for the clipping planes separately of the shadow map camera, independently of Z near Z far. But anyway, so we have rendered our shadow map. I'm going to end this first video off here. I was initially thinking about trying to let me commit these changes real quick. I was initially thinking about trying to do this entire thing in one video, but I don't want to have to put together a tutorial that's like an hour long. I don't think most of you want to sit through that. So I'm going to pick this point as a stopping point. Next time, we are going to figure out how to project the rainbow shadow map onto the world to figure out what's in shadow and what isn't. You know what? There's something that I want to do that immediately going to be productive, but I want to do it anyway, and that is, I want to actually draw something at the position of the player, just so that when I move around, like, this is a first-person game, we don't exactly have a character model, or at least this demo is first-person anyway. But I do want something so that when I walk around, you can see the position of the player reflected on the shadow map. So let's just draw one of the trees at the position of the player. That would be... let me just use like a tree or something like that. I want a shape that's more interesting than a sphere, and I don't want to render the player as the pirate ship because that would be weird. So let me just matrix set at the position of the player, which is player.xyz. Like this. And the vertex buffer will be one of the tree models. This can be vb_trees index, let's say index 0. I don't remember which model is which tree shape, but they'll all get the job done. Okay, so I don't think we'll actually see this from my my first-person camera because backface culling is turned on, but you can now see when I move around, as I walk around, we have a tree which is like running rogue in the middle of this forest, which is hilarious when I say it out loud that way. Anyway, we'll be able to see that the shadows that are cast by the player are update in real time, update with me, and they're not just static. That's one advantage that shadow mapping has over light mapping, but that's maybe a story for another day. So, again, the code for this, look for the GitHub repository down in the video description. Next time, I'm going to be continuing this and actually putting shadows in the world. I have a Patreon, so if you want to contribute towards these videos being made, there will be links to that in all the usual places. You could get some fun things like seeing your name in the credits, or hearing yourself shouted out at the end, or seeing a bit of a preview of my future plans. If you wanted to pledge, I would definitely appreciate it. Regardless, I hope you all found this useful, and I will see you all later. Special thanks to Army Armbuster, Edward Holt, Emily Koyo, GameMaker. Do I have to start doing disclosures now? Gunnar Clovis, Posho, Sindra Larson, Squarecode, The Nothing Happened, Tusk, and Zenjamins for supporting these videos. If you want to see your name in the credits or hear yourself shouted out at the end, head on over to the Patreon page down in the video description to join the fun.